Can you hear me now? Well. All right. Is that working?
Yep. Okay. The other thing you'll need to know is that the leftmost that you can walk is here.
Okay.
And the rightmost that you can walk is that microphone.
Okay. I put get a piece of gaffer tape to just
It's right here. I got it.
no, just yeah, I can keep talking. I can talk. I can keep talking about whatever you want me to talk about.
Monitoring attack surface and integrating security into DevOps pipelines.
Oh yeah.
Cool.
Lots of demos. Hope they work.
Can you just say random stuff?
Saying random stuff so we can get the levels set. Do I need to be moved back?
The microphone is moving a little bit.
Yeah. Okay. Is that maybe a little bit better?
Yeah, a little bit down so we don't get feedback.
Down from oh, okay.
Audio level down.
All right. I can talk quieter.
Turn the volume down a little bit more so you don't get as much feedback.
Oh, talking? Yeah, so I'd be talking like this, doing my demos.
A little bit. I still hear the edge of feedback a little bit.
Yeah, there's a little bit of ringing.
Sorry, I'm sorry I told you to turn it up.
Okay.
If you could keep
Oh yeah, I can keep talking.
whatever you can talk about the ratings.
Yeah. Trying to think of a reasonably clean story that's appropriate to tell in a mixed environment.
Who wants to hear a clean
Yeah, it's a professional conference. You don't want to. And I'm on camera. I've got certain words and hand motions that my colleagues have told me I'm not allowed to use in presentations. So. Okay. Yeah, that's a. We don't want no fights now. I'm a VI guy myself.
Linux or BSD?
I guess is OSX a. Is that enough of a BSD derivative to?
Ed is the best editor.
Yeah.
No, yeah, it's fine.
All right.
Longer feedback, I think we're good. What?
Normal talking voice?
Normal talking voice. All right.
So yeah, that's directly facing straight up on both volumes. Okay. So that should be easy.
Mm-hmm.
Hello? There I am. Sweet. This is where I do like the check 1, 2, check, check, check. Slovakia. Hello? Okay, it actually is on. Okay. Hi, everybody. So welcome to the second part of the DevOps Days Austin program. This is the part where we have multiple content tracks and all kinds of awesome stuff that folks have graciously volunteered to come and present to our community. And as we get started here, my name is Dan Zencraft. I'm one of the organizers, the speaker wranglers here at DevOps Days Austin. And really wanted to thank you all for coming out for this event. We're really blessed here in Austin to have such a great community. Allows us to bring out the great sponsors that we have and all the volunteers and everybody who makes this event really possible. This is year 6 of DevOps Days Austin. If you're unfamiliar, and we've upgraded, for those of you who've been here for a few years, we upgraded from a repurposed movie theater a couple of years ago. It really speaks to the growth of the DevOps movement. So anyway, so I know you all have digested some food, you've digested some Ignite talks, and you've had a lovely lovely walk down the edge of the stadium. As we were pointing out, it really is only 50 yards. If you think about it, and if you think about it even harder, you'll realize exactly how full of crap I am on that. So, with that, we have a number of just awesome speakers here and a lot of great content. So we're going to start off here. I'm going to shut up and turn it over to yet another Dan from Denim down in San Antonio, Dan Cornell.
Thank you. Howdy, everybody. All right. Whoa. So today we're going to look at some work we've been doing, looking at web application attack surface and watching how attack surface changes over time and looking at how monitoring those changes can help you make opportunities to do testing, application security testing, inside of your CI/CD pipeline. I've got a bunch of slides here. We'll motor through a couple of them pretty quickly just because you can download them and they've got instructions on how to replicate the stuff that we're doing here. But we'll talk a little bit about my background just to provide some context. I'll talk about, from a security standpoint, why attack surface is such a critical concern. And then we'll look at how attack surface fits in with concerns that people have as they are building applications using DevOps techniques. We're going to look at some technique or some research that we've done funded by the U.S. Department of Homeland Security called hybrid analysis mapping. I'll talk a little bit about the original goals of that research and then some of the additional things that we've done with that. And then what I want to spend a lot of time doing is going through some examples. There's a couple use cases for these techniques or this technology. And I want to run through some examples so that you guys can see the types of things you may want to replicate in your environments as well. Just a little bit of background about me. I'm one of the founders of and the CTO of Denim Group, and I'm a software developer by background, but really for the last probably 12 to 15 years, what I do is I work with organizations to help them understand the risks associated with the software that they're developing and to help them build more secure software. And so I'm a developer that's come into the world of security as opposed to someone with like a network pen testing background that is now looking at web and mobile applications. And that's some info about Denim Group if you're interested. One of the tools that we'll look at in the examples here today is OWASP Zap. Is anybody familiar with OWASP Zap? Fantastic. Hopefully now everybody is familiar with OWASP Zap, and I have a link to OWASP Zap so you can click and download it. OWASP Zap is an open source, freely available web proxy and also dynamic scanning tool. So it does dynamic testing where it'll spider an application and then go through some directed fuzzing of that application to identify vulnerabilities like cross-site scripting, SQL injection, different configuration issues and things like that. And we'll use OWASP for some of the examples. And a great thing about OWASP Zap is that it is, because it's freely available, it's the type of tool you can integrate into pipelines without having to go through a big procurement rigmarole. And it's got an open API, and so we can script different interactions with it, and that's some of the things that we'll be looking at today. I've got some example code bases, again, linked to Community Edition, as well as linked to some binaries or precompiled versions of the stuff that we're going to look at. All the stuff that we're talking about here today, you should be able to pull from the different GitHub repositories or pull the pre-built stuff, if that is helpful. Let's talk a little bit about attack surface. And when I talk about attack surface, when it comes to a web application or any application, you're really looking to see what are the different ways that an attacker can reach out and touch that application, or they can reach out and influence the behavior of the application. Because that's really what you're worried about. If you're building the system, you need to know, where am I going to see traffic or manipulation from someone that might be trying to get this application or get my application to do something that it's not supposed to do. From a web application standpoint, really what you're concerned about is anything in the HTTP request. So, the URL that they're requesting, parameters, headers, cookies, things of that nature. In theory, if you look from a purist standpoint, that application is running, it's pulling in environment variables and things like that. But really, if you've got someone who can control the environment variables that go into your web applications as it starts up, like you don't have an application security problem, you have an incident response problem, right? So it's a kind of a different concern. And so really for web applications, what we're most concerned about is all the data in the HTTP request that is going to be totally under an attacker's control. So you want to understand, for your running application, what are the set of URLs that this application is going to respond to, and what are the parameters that can be passed into the application that can potentially change the behavior, or that you're going to rely on to make decisions that will change the behavior of your application. If you look in a mobile application environment or an Internet of Things environment, the attack surface then gets even more scary and complicated. Today we're going to look specifically at web applications, but again, the techniques that we're looking at here could certainly be extrapolated or extended for other architectures of applications, but today we're going to look at web applications. And we're also going to talk about dynamic application security testing, and specifically in this case, we're going to look first, or both at automated dynamic application security testing, so using a tool like OWASP Zap to automatically exercise your application and look for vulnerabilities. But we're also going to talk about how some of these techniques can be valuable looking at manual penetration testing. All right, and manual penetration testing is not something you're going to fit into a pipeline, but and I love to see the level of automation and testing that a lot of folks put in. You're not going to be able to find everything with automation, and so understanding how your application has changed can allow you to better focus those limited manual testing resources that are going to be done out of band of the pipeline. But again, we're going to look at how understanding the evolution of an application's attack surface can help to optimize the way you allocate those resources. So what does attack surface have to do with DevOps? And this is more of a joke for the OWASP crowd. It seems like if you're going to an OWASP conference these days, your talk has to have DevOps in the title or it won't get accepted. I was giving a talk at Snowfrock, which is an OWASP conference up in Denver, and Jim Manico, longtime OWASP contributor, said, like, hey Dan, you got enough buzzwords in your talk title? I said, well, maybe I can fit a couple more. But really, we want to look at what do we want from security in the DevOps pipeline. So if you look at, if you look at organizations, Etsy, Netflix, they're amazing things to secure apps via the DevOps pipelines. And so, just as you've got this pipeline that's telling you at a component level, or my unit test telling me that this is working at a behavior level, is the entire system working together from an integration standpoint, right? You go through all this testing in your pipeline to understand, is this latest build of software at an acceptable level of quality, or does it have the right properties that I would consider delivering this or deploying this into production? And security testing should also be a component of that. You need to know, if I push this build out, am I going to expose an application that has unacceptable security properties, that's going to expose me to more risk than I think is acceptable? But there are some challenges that you see integrating app security testing into DevOps pipelines. So when we look at testing in a pipeline, there's a couple things that we need to do. First, we're going to have to do some tests. And when we look at testing in an app security testing in a pipeline, there may be some tests that we can do synchronously, right? We're going to kick off some tests and we're going to wait for those in order to feed into a decision that we're going to make, right? But a lot of application security testing tools aren't really geared well to run inside of a CI/CD pipeline. In working with organizations, kind of the range that we get back is, a lot of times security gets a time budget of about 8 to 12 minutes is the amount of time that they can take to weigh in with security's opinion on, is this build acceptable to move forward or not, right? And so it's not like you can kick off a 4-hour run with Fortify and say, hey guys, when Fortify is done, we'll get back to you, right? Or kick off some sort of for big applications, a full dynamic analysis test, really extensive testing. For security people looking to impose that, that paradigm on app security testing in a CI/CD pipeline, that's not going to be an option. And so you've got to look at the type of testing you're going to do, understand what sort of budget you're going to have, and then make a determination. For certain tests, do I want to wait for this to come back, or can I not wait for this stuff to come back? And so the testing, again, is going to be either synchronous or asynchronous. Then you have to make a decision. When we get the results of the testing, or at least for the stuff that we're waiting for, what do we do? How do we make a go or no-go decision about this build? And it's really interesting seeing folks coming at this from the security side, where they're like, okay, well, I want my policy to be that there's no critical or high vulnerabilities in the application, right? That sounds reasonable, right? Unless you've got an application that is just now starting to undergo application security testing, maybe you've got 100 cross-site scripting vulnerabilities floating around in your legacy code base. Hopefully there's a plan to get those fixed, but you can't break the build for 3 months waiting for all those things to get fixed. And so from a security standpoint, it's important in a lot of cases to be flexible. So you may not be able to mandate no critical or high vulnerabilities in the application, but a much more politically acceptable policy to impose is no new critical or high vulnerabilities in the application, right? Like, that's something that, from a security standpoint, well, okay, guy, I know we need to move fast. I know security isn't the only priority, but can we at least agree that we're not going to introduce new critical or high vulnerabilities? And so the way that you make decisions about app security testing inside of a CI/CD pipeline is going to be different than the way you would make decisions if for other parts of your application security program. And I think that's also an important thing to note. The app security testing that you can do in a CI/CD pipeline will not be the entirety of your application security or your software assurance program, right? What we're looking for are how can we identify serious vulnerabilities earlier and closer to the developers so that we can get them corrected faster and hopefully prevent them from making it into production. And so there are certain types of testing or certain activities that you can, that it's reasonable to fit into a CI/CD pipeline, but you need to understand that your app security program as a whole is going to also include things like longer running static analysis, manual penetration testing, threat modeling, so on and so forth. And so we're looking at, again, what kind of testing can we get done in a time-efficient manner so that we get, where possible, early notification of vulnerabilities that have been identified. And finally, we need to report on this. And we'll look at a couple different things, the kind of standard way that security likes to integrate or communicate, rather, with development teams or DevOps teams is I ran a scanner. Here's a 300-page PDF with a color graph on the front page. Right? Weird developers don't speak PDF. They also don't speak Excel spreadsheet. And so, one of the things that we've found is really critically important is you've got to take advantage, like looking at DevOps teams, take advantage of the tools that they're already using. And so we're going to look at ways that you can use things like chat ops to notify people of changes in application attack surface. Take advantage of Jira and other defect tracking systems, because that's where these things need to be reported for developers to, for you to expect that developers are actually going to go and try to fix some of these things. So again, many security tools run too long to be included, and security testing also includes manual testing. And so by tracking these attack surface changes over time, that can help us focus our testing activities and can also tell us when we need to trigger different testing activities. And so again, we want to focus our testing on, given our time budget, what tests can we run that are going to be the most likely of identifying newly introduced security vulnerabilities into the system. And we'll show kind of specifically how we can do that. And you can also, as you watch the attack surface evolve over time, use that to trigger testing activities to say, hey, we need to do manual testing of new features on this type of a schedule, or when we see these types of changes that have happened in the application. So the research that we did or continue to do with the U.S. Department of Homeland Security is called hybrid analysis mapping. And so our goal was originally to merge the results of static and dynamic testing. Is everybody here familiar with like static testing with a tool like a Fortify or a Checkmarx, Vericode's binary analysis, right? Where we're going to like look at software artifacts, either code or binaries. We're going to build a model of those and do things like semantic analysis, data flow analysis, control flow analysis to identify vulnerabilities in the software, potential weaknesses or vulnerabilities in the software. There's also dynamic testing, where we're going to spider an application like Google, except usually with some sort of authentication in there so you can see the entire application, and then we're going to do some directed fuzzing on the forms and the parameters and cookies and things that are passed in, looking for request and response patterns that indicate that there's a problem. Those are two very valuable and powerful ways to analyze software, but what folks find is there's overlap in what they can find. And so our original goal was to help organizations large organizations dealing with high volumes of testing data, to give them the ability to correlate those two types of testing together. And as you'll see, we've taken that research and we've extended that to do this attack surface evolution stuff that I'm talking about here today. So this was done just for trivia purposes. It was done with the Department of Homeland. It's a DHS, S&T, CSD, SBIR. The government loves acronyms, and I've conveniently provided again in the slides. You can take a look. It's been a really interesting program to be involved with over the past couple years. And also, one important thing to note, please don't assume that this talk is endorsed by DHS. This is just me talking about some of the things that we've done in this program, obviously not a formal endorsement of anything that I am all about. And so again, the original goal was to correlate and merge the results of static and dynamic testing. And after we did this, we found that there were some other really interesting and potentially, I think, even potentially more interesting things that we can do with the technology. And specifically, we were looking at integrating the results of Fortify SCA on the static side and AppScan on the dynamic side. because we saw a lot of organizations that had adopted those two technologies prior to the acquisitions by HP and IBM, and then kind of the situation they found themselves in is, well, I have these two different data sets coming from two different vendors that don't necessarily have a strong interest in cooperating with one another, right? Because they're direct competitors. And when you go to an HP shop and you're like, well, just get rid of AppScan and use Web Inspector, like, no, we're not real excited about doing that. Similarly, flipping it around, looking at pulling out static analysis tools. So again, dynamic application security testing, we're going to spider the application, find all of the URLs this application will respond to, find all the parameters that get passed in. Again, with some sort of authentication and session detection so you can get past login pages. And then you're going to fuzz to identify vulnerabilities. And so if I send a SQL control character in and I get a JDBC error message back, that's the type of pattern that would make me say, I believe that this application has a SQL injection vulnerability. And a finding for us in the dynamic world uses the vulnerability type. We use MITRE's common weakness enumeration, the relative URL within the application, and then for certain classes of vulnerability like a SQL injection or cross-site scripting, we also need to know the parameter or the header or the cookie that you passed in. So that's what a unique finding looks like. In static application security testing, again, we're going to take the source of the binary, create a model of the application, and then we're going to do data flow, control flow, semantic analysis. So here's kind of a textbook SQL injection. An attacker controls the return value of that request.get parameter for username, and that then taints the string username variable. That tainted username string then gets combined with this static text, and that in turn taints the SQL string variable. Then that tainted SQL string variable is passed into the sensitive function which execute. Again, kind of a textbook example of where an attacker can control and override or modify the structure of this SQL query such that they can do bad things. So really the problem that we're trying to solve, or the way we went about trying to solve this problem, is to figure out how does code for a given application translate into behavior, right? So for a given language, for a given platform, we need to know, if I'm seeing behavior from a dynamic standpoint, what code is responsible for that? And similarly, as the code changes, how does that potentially change the dynamic or the running behavior of the application? And so basically the way that we solve this is we wrote a parser that goes in, detects the language and the frameworks that are in use, and it builds an attack surface model of the application. So it figures out, again, every URL that the application will respond to, every parameter that can be passed in that will potentially affect the behavior of the application, and we keep track of the source code responsible for each of those points on the attack surface. And so to merge results, basically you just query. So if I have a dynamic result, says I have a reflected cross-site scripting for login.jsp for the username parameter. I query the endpoint database and it says this is a Java Spring application that's in com.whatever, login controller.java line 62. I check my findings on the static side, and if I have a reflected cross-site scripting that starts at com.whatever, login controller.java line 62, I can say these are two pieces of evidence I have about one vulnerability. It's not two individual findings that need to be triaged separately. Right? So magic. But the question we then had was, what else can we do with this? And from an attack surface standpoint, that lets us start to do some really interesting things. If in a case where we've done dynamic testing but we haven't done static testing, but I have that model, I can take the finding and get an answer of, well, where in the source code do I need to look to start fixing this, right? And that's not as good as, I don't know if folks have ever used like the Fortify or the checkmarks plugins for IDs where they show you the full controller data flow. It's not as good as that, but at least gives you a starting point to, go about tracking down the issue. What we also found is that we can take that attack surface and we can precede dynamic scanners with that data. So instead of having to spider the entire application to guess at what the attack surface is, we can just preload the entire attack surface into the scanner so that it gets a better picture of the entire application. So why would we want to do this scanner seeding? The challenge with spidering is there are a number of situations that spiders are often bad at finding. If you have landing pages in your application that link back in to other parts of the application but where you would never link out to those, those are going to be missed in by your typical spider. If you have hidden directories that have been added to the application, an interesting thing that we find in a lot of cases are hidden or unused parameters in the application where you would never see that in the HTML or the JavaScript crawl, but the application will change its behavior based on them. I once worked a long time ago, worked on a cold fusion application where, just because of cutting and pasting, if you passed a parameter named D to any page in the application, for whatever value you passed in for D, like let's say we passed in the value 1001, it would delete order 1001, right? So that was a behavior of the application. You would not know that from a crawl standpoint, but for, and I don't think it was anything malicious, but that was just the way that the way that the application was built, probably as a convenience function. And so you find when you're doing tests, you find these convenience functions, you find debug stuff that's makes its way out into production applications and things like that. And so we've actually built plugins for Zap, Burp, and AppScan. I think Zap and Burp are released to AppScan. I don't know if that's public facing yet. But that lets you basically point at an application source code and precede the scan so that you can identify these potential issues. Another place where this is helpful is if you have multi-step processes. In a lot of cases, like a checkout process, a lot of times the spiders aren't smart enough to figure out, like, how do I get in an appropriate state so I can go to the next step and go to the next step. Again, this preceding can identify those situations. And this is also helpful in enumerating things like REST APIs for single-page web applications and stuff like that, or the backends for mobile applications and whatnot. So, really, really handy to know what are all the things this application might respond to so that you don't have to guess and find all of those. And the advantage of preceding, or of having all of the attack surface, is it makes sure you can both scan and manually test all of the application. And so you reduce the incidence rate of false negatives, which would be situations where you did testing but didn't find vulnerabilities that were there. You can reduce the incidence rate of false negatives because you're getting better coverage of the application. So one of the ways that we've made this stuff available is through a command line client that you can basically point at. You can basically point at some code, and it will go through and dump out here, and it basically says, hey, for this particular application, here's all the pages that we're going to respond to, here's all the parameters that can be passed in, and here are the different HTTP methods that can be used. And you see how fast this is running. Like we have a very simple tokenizing parser that's going through. So we're not going through and doing like full control flow or data flow analysis that you would see from like a Fortify or check marks. Again, one of our goals here was to be able to run this analysis very quickly, and that helps us a lot. Again, when we're trying to integrate testing into pipelines, and so the analysis that's being done is not deep. It's just finding out what we need. But an interesting thing that you see from looking at these different, looking at the parameters that can be passed in, for most frameworks, we're smart enough to know how the auto binding works, and we're parsing the model classes as well. And so we can identify situations like this, where if I'm a manual pen tester, I might look at this and say, you know what, it's weird that I can pass in the ID for the pet type, right, that I can control from the client side. I can control that value, what that value is set to on the server side. From a manual pen test standpoint, that's valuable, potentially valuable information to have, and it's also good to make sure that stuff is getting fuzzed as well, because a lot of times when you're developing software using those auto binding things, if you don't explicitly think about what should be auto bound or not, you can end up in situations where you're exposing stuff that you don't want to expose. Again, we can also go and so we can look at the Zap plugin here, where we're saying, I want to import endpoints from source. That's where the source code for this is located. This is where the running app is located. And given that, the scan that we're going to run here is going to find things like this admin.jsp page that I wouldn't necessarily know about unless I had trained it to log in with an administrative user. And you'll also notice a bunch of these pages have these debug parameters that can be passed in. What do those do? I don't know, but I certainly want to include them in my fuzzing, and if I'm doing manual pen testing, I want to do that as well. So what we looked at then is saying, okay, these are things we can do with the attack surface at a given state and time. And again, I think that there's some really valuable stuff that we've been able to pull out of just looking at attack surface when it is stationary. But it's also really interesting to look at how attack surface changes over time, because again, that gives you insight into how the application is changing. This is from an actual call with a customer, giant bank. And they are very concerned about attack surface, and I was talking through some of the research that we'd done, and the client contact said, and this, and all this functionality is now available in the crappy form of code that you write, and I said yes, which is how things get developed. I do weird stuff that I find to be interesting, and then I go to the engineering team and dump it on them, and they shake their fists at me and rewrite my crappy Python in much better Java. I don't know why, I don't even actually know Python that well, so I don't know why I use it for all the stuff I do. I'm really a Java developer by background, but whatever, that's just the way that things work. And so one thing to note, if you want to try this stuff and play around with it, there's probably, we've got some mitigations in place. This stuff hasn't been very thoroughly security tested. It's more to wire up a couple proof of concept on some client sites and to get some things working. I wouldn't want to attach any of this code to like a network socket or an HTTP server that didn't authenticate or something like that, right? You don't want a bunch of random stuff being passed to this this code. And so, but again, we've got this attack surface lib, and what it does is it takes the JSON output of that endpoint CLI, and it creates attack surface tree data structures, and you can run diffs on those data structures. And we also do some Git utility stuff in the background. And so this code is the basis for the stuff that we're talking about here. One thing that we can do by converting the attack surface into tree data structures, we can start to look at, visualize what the attack surface looks like. That's moderately interesting. That would probably be more interesting in the hands of someone who had better user experience or graphic design skills than I do. But we can also start to look programmatically at how an attack surface has changed. And so if we look here, this. So what we'll do is we can feed this 2 different Git commits. And so what we're doing here is we're going to calculate the attack surface, and then look at how the attack surface has changed between those 2 Git commits. So what we see here is that we've added the attack surface of these 4 pages. We haven't deleted any attack surface, and given the size of the application, we've added we've added a URLs equivalent to 30% of the application, right? And so what this lets me do is to see, again, between the last checkout or the last Jenkins run and this Jenkins run, this is how that application has changed. Now, I talked a little bit before about how a real challenge that we're looking at here is how do we correlate between the behavior of a running application and the source code that is making the application do what it wants. Right? So if you look at new files that have shown up, new parameters that have shown up, again, those are, in those situations we can say, well, this is new, this is totally new functionality. We can also do some kind of kludgy analysis to say, let's look at the files that have changed, and let's look for attack surface that is associated with those files. That doesn't mean that the behavior has necessarily changed, but it will let you say, hey, given the files that have changed, some of those files are associated with behaviors. If we're looking for a wider set, like, hey, I know this stuff is new, but I know in a wider sense, like some of this behavior might have changed. And so, is it perfect? No, but it provides us with some additional information that's potentially valuable. And so here we can look at a more complicated example on our ThreadFix application code base. And so here we're looking between, I don't know, like the 2.3 and the 2.5 release or something like that. And we see here's all the stuff that has been added. Here's another set of URLs that we believe has changed. And here's our added percent was 24.4, deleted percent 13.3. And there were enough files changed that it looks like almost 77% of the application behavior may have changed. And so by doing that, essentially like similar to doing a code diff, we're looking at all the files that have changed, correlating that back to the applications and the attack surface to identify what's new, what went away, and what are things that potentially could have changed based on updates to the application. Okay, so how can we use this in our CI/CD pipeline? The most valuable thing that we've found that we can do is we can do very targeted dynamic application security testing based on this data. So we can essentially say, hey, I want to run an authenticated ZAP scan against the 3 new URLs that were added based on this most recent commit. Right, so that lets us, again, we're trying to get into this very tight time frame. That lets us get really, really narrowly focused on the testing the parts of the application that are the most likely to have introduced net new serious vulnerabilities. And so, and we can also do things like communicate out to again, like notify Slack or notify HipChat to say, like, hey, this last commit just added 3 new URLs. You can use that to create JIRA tickets so you get a backlog for manual pen testing and so on and so forth. So we'll look here. Okay. So what this is doing is this is just looping and watching a Git repository to look for net new commits that have come in. So if I searched JSP to So if we add FP, so I get add search, get add basket, get commit, new stuff. All right, and if I do get a new session here. And if I do a get push, as we watch that Git repository to look for the latest change, it picks up that these new URLs or that these new URLs have been added, and then we can go and run that very tightly targeted ZAP scan against those new URLs. And what we find here is that for one of those URLs that was introduced, we found a critical or high vulnerability, which was this reflected cross-site scripting, right? So based on that, we can say, hey, our policy is you can't introduce net new reflected or cross-site scripting, SQL injection, or other serious vulnerabilities. And so we can make a determination to say we're willing to fail the build based on this very targeted testing. But if you saw with those 2 new URLs, that testing ran in a matter of 10 seconds, 20 seconds, or something like that. So you're getting that very targeted security insight into the changed security state of that application. That that then you can make a determination, do we want to pass or fail the build based on that? And you wouldn't be able to do that if you were doing a full crawl of the entire application, especially as you start to look at large applications, large APIs, and things of that nature. And also, just for the fun of it, again, we can post things out to HipChat or to Slack, because everybody has to have their chat ops. We can auto-create defects in JIRA based on that, and so on and so forth. And just for the record, the architecture of that demo done live is we push stuff into the NuGet repository, or push that out to GitHub. That gets pulled down to GitHub or to a local copy of the repository. The monitoring script detects the changes, tells Zap to do the testing, talks to JIRA, talks to Slack, talks to HipChat. Not a recording, done live. So, with that, open that up to, so next steps for this stuff, we need to expand the model that we have of application attack surface. Right now we're very focused on parameters and HTTP verbs. We're going to be adding HTTP headers, such as cookies. And I also think this is really interesting to look at for other application types, because the challenges you run into in a lot of cases are, much more complicated questions of attack surface in IoT or mobile application systems, and being able to quantify and track attack surface over time for those more complicated architectures is has the potential to head off a lot of really nasty security issues before they get pushed out in production. And I think I have 1 minute left to probably answer a question, or I'll be again around here for a while if folks have things after that. Any questions? Yes. So. Okay, so the question is if we're feeding this like the parameters and stuff to Zap and the verbs and whatnot. So we're interacting with Zap. There were kind of two different things that we did with Zap. In one case, we said to Zap, hey, here's all the URLs and all the attack surface and all the parameters, so that Zap doesn't have to go through the spidering process in order to discover that. So again, hopefully we avoid false negatives by more thoroughly testing the application. In the second case, we were saying to Zap, hey, I only want you to look at this very select group of URLs and parameters. I don't want you to do the full spidering process. And so by calculating the full attack surface, you can feed that for longer running testing. Or if by calculating the diffs, you can have Zap run in a much more targeted way. Does that answer your question? Okay, perfect. Well, good. Thank you all very much. Oh, thanks.
Thanks so much.
Thank you. All right. Thank you. There we go.
Okay, everybody. A couple of quick announcements. We are on break till 4:05. A couple of things going on is there's some ice cream if you want to take a quick jog back the other 50 yards and come back. You can kind of burn off the extra.
That works. Okay. We got a test. I can hear myself. You guys can hear me. Everyone's got ice cream. Okay. Oh, it's touching my lips, should it be? I just don't want it to, like, why do I hear rubbing through Derek's whole talk? Every time his mouth moves, it goes. That's right. I did shave. That might help.
There you go.
Okay. No, it just fell. Okay. I have it going up my nose by the end of this presentation. That won't sound good. Okay. All right, we'll try and keep it in. Are we ready?
I think we're ready.
Okay, I'm ready.
Ready to go?
Yep.
Who said 3 minutes? No, I think.
Go, don't go. Go, don't go. Go, don't go.
Yeah, let's get started. Okay, so welcome to session 2 in the afternoon of for DevOps Days Austin 2017 here. I hope everybody got a good dose of ice cream if that's what floats your boat. Apparently we had Star Wars themed flavors down there. Amy's ice cream and
It was good.
and
I can
whatnot was
attest
good.
to it.
Right on.
I had Death Star chocolate. It was awesome. I'm totally psyched and ready to go.
So is chocolate the flavor of the dark side? Yeah, there we go. All right. You heard it here first, folks. Scientific evidence. All righty. Okay. So, right on. Well, I'll go ahead and introduce Derek Weeks, VP of stuff at Sonatype.
Yeah.
Going to talk to us about Deming in Detroit and the lessons learned about security and quality as it applies to DevOps.
Excellent. Thanks, Dan. Much appreciated. Well, hello, everyone. I'm really excited to be here because for this session, you guys get full access to some of the great research that I've done over the last couple of years that I want to share with you and give you some insight into what's happening in the software development realm, some of which you might understand, but you might not understand the volume at which it's happening. So let's get into it. In 1982 in Detroit, I was just in Detroit a couple of months ago, a city that's changed dramatically over the decades. In 1982, they were rolling off 4 million cars on the production lines in Detroit every year. There were 15,000 vehicles rolling off the production lines every single day. It was line workers like this that were focused on getting those vehicles off the production lines as quickly as possible. Their main incentive in this process was velocity, right? If they had the wrong brake assembly to go on that car, if they could make it fit, they made it fit and the car kept going, right? If the wrong bumper was there and they could make it fit and they could fix it later in a big lot outside, they did it. The production line had to keep going, 15,000 cars a day. So Deming said you can't inspect quality into a product. That production line worker had absolutely nothing to do with the quality of the product being shipped off that production line. If you were worrying about defending quality at the point where you're producing the product, it's too late. The quality selections had to happen at the beginning of the choice of the parts that were responsible, that were required for going on to those vehicles. So in 1982, this is also the year that Deming wrote this awesome book called Out of the Crisis. And Out of the Crisis talked about how he was educating U.S. auto manufacturers and other manufacturers to follow the lessons that he had been teaching for decades in Japan. Because over the past 20 years, between 1962 and 1982, the Japanese took 20% of the U.S. auto market. They went from a 5% share to a 25% share by 1982. And the way that they did it was they focused on quality of what was rolling off and then pairing that with velocity. They picked the very best parts from the start to put in their vehicles and have them go down the production line. So how does that relate to software development and what we're doing now? Well, the way that we're developing applications now is we've all seen the migrations from waterfall to agile to DevOps, DevOps specific practices, and the focus of those practices, a lot of it has been on velocity, right? But to maintain that velocity, what a lot of organizations are doing is they're not writing code from scratch anymore. In fact, they're assembling it from open source components. And most applications today, a traditional application today, will be 80 to 90% of the footprint of that app is open source components. Because if I can pull a crypto library or a logging framework or a web application framework or anything off the internet in a second, it beats coding that from scratch and delaying my release times, right? I can rely on the expertise of others to meet my deadlines, improve my quality, and get my product shipped out faster, right? Well, the interesting thing is, in this book, Out of Crisis, that Deming wrote, he was talking about the Japanese versus the U.S. auto manufacturers and the fact that the Japanese in 1982 owned about 30% of the parts that they were putting into the vehicles. All other parts they had outsourced the production of to their partners that knew how to develop the best and highest quality parts for those vehicles. The U.S. auto manufacturers at that time were the complete opposite. 80% of what they were putting into the vehicles they owned. They outsourced very little. So the Japanese looking at, we're going to bring in 70, 80% of what we need from elsewhere because we're not the experts in building it ourselves, is actually reflective of how we're building software today. So Deming had three key principles that he really emphasized in his lessons. You know, Deming is great. If you haven't read any Deming and you're trying to learn more about DevOps, pick it up because they're amazing lessons to learn that were taught decades ago, 35 years ago in this case. But Deming said if you're going to build something, you have to pick the very best quality parts. And you have to pick those from the highest quality suppliers out there that have a consistent track record of delivering good things to their vendors that need them, or to their the manufacturers that need them. And then he also said you need to track and trace these parts over time, because if something goes wrong, let's say a Takata airbag has a defect in it, you need to know where those parts are and how they're being used and who's using them so that you can recall them, fix them, and get things running in an orderly manner again, right? These same lessons will apply to how we build software today, and I'm going to share with you some of the research that plays into that. So how many of you know Sonatype as a business, other than it's on everyone's lanyards around? So Sonatype has something called the Nexus repository, but I'm not going to give a product pitch. We have other products as well. But one of the things that we do that you may or may not know is we run something called the central repository. And if you're a Java developer and you're looking for open source components, you go to the central repository to get those open source parts and download them and use them in your software. So we have a huge volume of consumption from that repository, and what I've done is document a lot of the data from that, and I'm going to share that with you to give you a sense of how much development is really happening with open source components and some of the quality implications of how development is working. And what I found through all of this research and what I've revealed in the data is certainly not all parts are created equal. We say they age more like milk than they do like wine. So older components aren't necessarily as good as the newer ones. And to make this easier to kind of comprehend what's going on, I want to talk about software supply chains. It's a term that you may have heard of. Recently, even I think Jez or Damon mentioned it this morning within his presentation. A software supply chain is very easy to understand. You have a number of suppliers. These suppliers in this case are open source projects. They are the groups or individuals that are building software that they are making freely available to others. Now they make it freely available by putting it into these public warehouses like Maven Central, npmjs.org, the NuGet Gallery, rubygems.org, python.org, whatever kind of development you're doing, there are different repositories out there where these are available. Those components are downloaded by the manufacturers or the software development teams that are using these components to build their finished goods. And then they are using those components to create the software applications as the finished goods and releasing those to their end users, right? This is how the open source components and open source software supply chains work. Let's think about Docker, right? I have an application. I put it in a container, right? I'm a supplier. I put it up on Docker Hub, right? You want to download that image because you think that particular application in that container will help you. You download it and you turn it into or plug it into your infrastructure in dev or test or production, what have you. Containers also get represented and consumed by this software supply chain. Every one of you developing software has a software supply chain today, right? You might not have thought of it as one, but it exists, and it exists in huge volume. So let's talk about the suppliers and the data that we know about the suppliers. So there's a site out on the internet called modulecounts.com, and it has a specific function. The only thing that it does is it tells you how many open source components there are across how many projects and how often they're releasing. So 1,000 new open source projects come online every day according to the data from modulecounts.com. Of all the open source projects globally, 10,000 new versions of their projects are released every single day. When I did an analysis of 380,000 projects in Maven Central or the Central repository, they released on average 14 times a year. There is a massive supply out there that is freely available to all of us that are consuming this, right? How much consumption is taking place? In the Central repository alone, there were 52 billion download requests that we handled last year, right? There are about, to put this in context, I joined Sonatype in 2013. We had just done 13 billion. There's obviously a huge amount of growth. Now in 2016, 2015, 2014, 2013, and probably 2012, there were about 10 million Java developers on the planet. They are the people consuming these components. The population of Java developers is not growing exponentially. The availability and consumption of the components is growing exponentially. And it's not just Java components. The NPM guys published this back in, I think, October, November on the consumption from npmjs.org. They were hitting a range of 52 billion downloads, or about 1 billion downloads a week on average is the volume that they were hitting. At one point in November, they had a week where 1.6 billion NPM packages were downloaded, right? The volume, not only in Java, but in NPM is massive. On February 14th, Donald Stuft, he works for the Python Foundation. He said they had I think it was annually 4.4 billion requests for Python packages being downloaded. And he published these charts with over 1 year. They were basically doing 5 times the volume over 1 year of downloads from the Python repository. So across anything, any ecosystem, any software supply chain, the volume is going up tremendously. Docker containers that I mentioned before. A couple of years ago, they were about a million downloads. This year, they're expected to do 12 billion container downloads from Docker Hub. If you don't think software supply chains are in full effect in your organizations, we need to pay more attention, right? Because you're bringing in things into your organization that you might not understand. This is a map of the PyPy packages and dependencies. 2 different ones, Sphinx and 6, right? This is a map of all of the dependencies and packages that are coming down when you ask for Sphinx, and you get all of the dependencies in the package along with it. In some cases, there are a few, a couple, 10, 100. In some cases, there are a couple thousand dependencies coming along with these packages. When you request one thing, you might get a large group of other things that are being brought into your organization. Now, what else did the data tell me when I looked at it for what was being downloaded? Year over year, when I started doing this report called the Software Supply Chain Report, and I'll give you all a copy of it. In 2014, 6.2% of the components downloaded from Maven Central had a known vulnerability in them. And that's gone down to 5.5% in last year's downloads, right? Now, 5.5%, hey, that doesn't seem like a lot. That's like 1 in 18, 1 in 19 components that you've downloaded has a known vulnerability. 1 in 20 parts. Imagine 1 in 20 parts going into Toyota's vehicles having a known defect, right? Production at high velocity cannot work at this in this particular capacity long term, right? You can't have 1 in 20 parts going into your products that actually have known vulnerabilities, right? So none of you in this room are downloading billions of Python packages or billions of Java packages or billions of containers. But when I looked at the average organizations, this is some of the data from the new report that we'll publish in either late June, early July this year. I looked at 7,500 organizations. The average organization was downloading 125,000 components, Java only, into their organization. I only have access directly to the Java data. I looked at the IP addresses, matched them with the companies, right? And when you look at that volume coming into the organization, it's also interesting to see if you only wanted the very best versions of those parts, right? Or if you want to know how many versions you are bringing in, you're bringing in just over 3,000 different versions of parts. But you're downloading those on average 125,000 times a year, right? If you only wanted the very best version of each part, you would only need about 1,300 unique parts, right? We want to work with the best suppliers, the best versions of those parts, and we want to track and trace them over time, right? When I looked at the number of security vulnerabilities associated with these parts, 5.8% across that population of 7,500 companies, 5.8% of their downloads had known security vulnerabilities the day that they were downloaded, right? Now, you might be thinking, hey, just because I downloaded them doesn't mean I'm necessarily using those in my apps. Like, we have policies, right? You can't use bad stuff. If there's a vulnerability, we catch it, right? There's an open source governance board. They'll check it. We do, you know, quality and security tests before it goes out the door. So when I looked at, this was last year's data because I don't have the full picture for this year, 6.1% of the downloads last year had known vulnerabilities. When we looked in repository managers, kind of a local place to store these components, like our Nexus product, 5.6% of the components there had known vulnerabilities. When we did an analysis of 25,000 applications that end users gave us for analysis, 6.8% of the components in that 25,000 applications group had known vulnerabilities. And that means from the beginning of the software supply chain to the end of the software supply chain, the vulnerable components are making their way freely through these organizations, right? There's a great report, it's on the slide, Thou Shalt Not Depend on Me, done by the guys at Northeastern University, that talks about JavaScript vulnerabilities. When they looked at websites like 300,000 websites, 330,000 websites, and they looked at NPM packages being used on those websites, 37% of the websites out there using jQuery had known vulnerable versions of jQuery. 87% of the handlebars usage, 40% of the Angular usage had known vulnerabilities in those websites. It's a heavy academic report, but if you're into this kind of stuff and you geek out on it like I do, then it's fascinating and worth discussing. So is part of, you know, when we think about working at high velocity, right, these components are not all bad. We're benefiting tremendously from using these components or containers in what we're trying to do because it increases our velocity, it increases our efficiency, right? But at the same time that we're trying to increase our velocity, there are people in the organization like security professionals that are trying to keep up with what's happening in DevOps. And those people are totally outnumbered from a standpoint of there's one application security professional per 100 developers on average, right? You're outnumbered by the number of developers. You are outnumbered significantly by the number of components that they're bringing into the organization that you have to try and evaluate, right? And the only way to do this is the answer that a lot of things that we're doing in DevOps ends up being is you have to find new ways to automate evaluating what's coming into your organization. Otherwise, you're bringing in things from unknown origins of unknown sources. So there are, in addition to this data that I've run in this report, I also run an annual survey. This year we surveyed 2,300 IT professionals. We asked them, do you have an open source policy within your organization that says you have rules about what you can bring in, what you can't bring in? So about 6 in 10, or 57%, 58%, have a policy that says, here, we know what we're supposed to bring in or what we're not supposed to bring in. It's not necessarily automated, but it's certainly information that tells them, or they know there are rules about what we can bring in or not bring into our organization. But that means 4 out of 10 can bring in anything that they want, right? Anything that they want when 1 in 20 things that they're consuming has a known security defect, right? So if we were to develop a policy, what did the data that I have show about what might make good sense? So one of the things that we did when we analyzed this group of 25,000 applications, we figured out how old the components were within those applications. So so this chart says, the blue line says 1-year-old components made up about 18% of the app. 2-year-old components were about 21%. 5-year-old components were about 8%, 9% of the applications, and so forth, right? The red line shows the number of, or the percentage of components in that grouping that had known vulnerabilities. So components 1 to 3 years old, about 5% of those on average, let's say, had known vulnerabilities. When you get to the 8, 9, and 10-year-olds, you're closer to 15% of those components had known vulnerabilities in them. So if you are going to set a policy for what you should use or not use within development, if you set a policy to say you can use any open source components you want, we don't care, any versions you want, in fact, just they can't be older than 3 years old, you can actually eliminate like 50% of your security vulnerabilities of what you're putting into your applications today. Right? So the other thing that we found out that was kind of cool, if you geek out on data like this, is 1-year-old components. This chart says the 1-year-old components that were on the latest version. This is about 13% were on the latest version. 4-year-old components, about 11% were on the latest version. 9-year-old components are 20% of those are on the latest version, right? So these are in applications that we analyzed last year, right? When you look at these aren't applications that have been around forever. These are newly developed, under development applications that someone wanted to analyze, right? So they're 20% of the 9-year-old components are on the latest version, right? In 2008, someone developed that piece of software. You are using it in your application today. It has a 3 times higher vulnerability rate than the younger components. And because that one is on the latest version, right, there have been no new versions of that released in the last 9 years. It is either perfect software, right, 2008, right, I built the perfect piece of code, never needed to change it, right, or it's a dead project. If there is a security vulnerability in it, there's no remediation path other than going to a brand new component. No one maintained that project, right? When we ask in this survey that I did back in February, the 2,300 people, do you have track and trace capabilities for all the components that you're putting through your organization? 35% said we have a full software bill of materials. We can track and trace everything that we put into our software in development that went out to production. If anything went wrong, we know where to track and trace it, right? 65% don't have a complete bill of materials, right? So when the latest struts vulnerability came out, or commons collection vulnerability came out, or the OpenSSL Heartbleed vulnerability came out, if you went on a scavenger hunt where you assigned 3 or 4 people to go and find those components in your infrastructure, you don't have a complete bill of materials. If you did, you just look at the list and say, we know what we're using, where it is, and we can go and remediate it. So 65% of people are looking at scavenger hunts every time a major vulnerability comes around. And when it comes around, right, I also have data that shows me kind of what's happening with these vulnerabilities. The commons collection vulnerability. Foxglove did an awesome report on the commons collection vulnerability. PayPal also did an awesome blog on when they found commons collection as a vulnerability in their applications, how they had to track and trace it down through their environments. If you remember anyone know, or you maybe can't read what this is, Hollywood Presbyterian Hospital. You know why that is an important location? They were held hostage, ransomware, right? Anyone from San Francisco here? Right? The San Francisco Municipal Transit System was giving away free fares all weekend in November, this last November. You know why? Ransomware, right? They were able to get in through the commons collection vulnerability in their applications, hold those organizations for ransom. And when I looked at, we did an analysis of what are the downloads from the central repository of commons collection. Last year, there were 23.4 million downloads, and 78% of those were the known vulnerable versions. There are perfectly safe versions available, but the downloads, the vast majority of the downloads, are all the vulnerable ones, right? If we look at Struts 2, this was a big vulnerability, I think, announced in March. A lot of people were concerned. The Canadian Statistics Office, Canadian Revenue, Japanese Post, they all went down due to Struts attacks vulnerabilities, right? There were, of that particular vulnerability, there were 279,000 downloads across 2,700 different organizations in 2016, right? The number, when there are perfectly safe versions, good versions from good suppliers, right? like Bouncy Castle, great, great open source project. They're a crypto module. When they have a problem in their crypto module, they repair it immediately. And yet still 50% of their downloads, like 11 million last year, were the known vulnerable ones. So we need to be careful about what we're bringing into our organization. In the survey that we did, we also asked the question, is security a concern when using containers in your environment, right? 88% of those said security is a top concern within our environments. But when we ask, do you have any tools that tell you about security configurations or problems within those containers, only 50% of people said we actually have tools to assess and help us analyze the security of our containers. We also asked the organizations, have you experienced any breaches related to web applications or related to open source vulnerabilities in your applications? We asked the same question in our 2014 survey, and the number of or percentage of breaches within an organization went up 50% over those 3 years. We had this year 1 in 5 organizations said we had a breach, or we had or suspected a breach related to a web application or an open source component vulnerability within our applications, right? So when we think about, there's all this data, there's all this volume of stuff coming into my organization, what can I do? If you are relying on manual processes to try and evaluate what's coming into your organization, you have been outgunned for like 8 years, right? Maybe 10. Right? You couldn't keep up back then. You have to find ways to better allocate the human effort, which is a lot of what we're doing in DevOps, right? Where do we have constraints? Where can't we keep up? How do we keep up with trying to assess what we're using within our organizations? The good news is more of us are keeping up. So this same survey that we ran in February shows that, let me walk you through this. The blue bars, when we ask in 2014, where have you automated security practices across your development lifecycle? The purple bars are this year's survey when we ask, if you're a highly mature DevOps organization, where are you using more mature or more automated software security practices across your development lifecycle? So you can see there is a steady growth, and where it's relatively even across the 2014 responses, we actually have more people bringing security earlier into the lifecycle. So we know the patterns are happening. It's not like people are not doing this. More people are taking these practices into account, and there are a lot of different technologies that can be applied into solving these particular problems. So this is, I'm just bringing up a couple of screenshots of different things that organizations are doing, but for open source components, this is a view of a developer's IDE. We could show that this is the version the developer selected. Every column here is every version of that component that's available. The red, orange, and yellow marks say these have known security vulnerabilities. There might be a license risk associated with that. The height of the bars here show the popularity of the consumption of those components over time. So if I move to this particular version of this component, I don't eliminate my security risk, but I might lower my security risk. How can I help empower developers early in the development lifecycle to make better choices of the components that they're using and they're consuming, right? A software bill of materials. There are a lot of different organizations that offer either free or commercial versions of something that can give you a software bill of materials. What's in your applications now, right? Are 6.8% of your components in your application that you're building now vulnerable? So there's a link in here. You could run a free software bill of materials report and get a sense of what components am I using here? What are the vulnerabilities, license, architectural security? How popular are those components? How old are those components, et cetera, that are available? So there are free services from OWASP to Sonatype to Veracode and Black Duck and other organizations that offer some form of this that you should probably think of taking advantage of. You don't just have to come to Sonatype to do that, but there are tools that can enable you to do this. This kind of analysis can take 15 seconds, right? It's not like send it away for 8 hours or 8 days and we'll give you a response. So if you want a copy of the 2016 Software Supply Chain Report or the DevSecOps Community Survey that I mentioned throughout the discussion, my out-of-office email is on. If you email me at weeks@sonatype.com, it comes back with a link or a couple of links that say, here's where these reports are on SlideShare. You don't have to register. I am not going to spam you or anything like that. It's just an easy way to get you the slides or the reports. Well, you can get, there's a link to the slides and a link to the 2 reports in that. And I think that's all that I have to say. And if we have time for questions, I'll answer them. Otherwise, I am here for the rest of the afternoon and tomorrow as well. So thank you. Thank you. You're welcome.
Folks, I believe they still have a few books for signing in 927. If you want the DevOps Handbook, it's free. All signed by all 4 authors. Suite 927.
And don't forget, as you're making your evening plans, there's a happy hour. So we got one more session. And at the end of after the closing today, there's a happy hour just immediately south of campus here. It's a short drive, short bus ride, or a short walk, right over by Schultz's Garden for those familiar with the area. If not, we have maps over in the main room for where to go. Happy hour tonight, some free drinks and a lot of fun games in a really cool venue with music and bands and DevOps people playing in jam bands, apparently. So be sure and come on out for as much of that as you all have time for.
Testing, testing, hello, hello. I can speak a little louder, but alright, I am standing between everyone and happy hour, so we get this show on the road. Does that sound good? Alright. Yeah, so I'm waiting for folks to arrive, and then we can all saunter on over to Schultz Beer Garden for happy hour on Trinity. Okay, cool.
We're not getting your video up here.
It should be.
Okay, folks. So welcome to the last session of the day in the track. One of the things that we're doing new and different this year is we're incorporating more and more local user groups and parts of the local community into what we're doing here in DevOps Days Austin. With that, we've got Ryan Joy from Refresh Austin, and he'll tell you a little bit about what that organization does and talk to you a bit about front-end development and DevOps.
Excellent. Thank you so much, Dan. Yeah, so thanks to DevOps Days for the invitation to Refresh Austin and reaching out to local user groups. I think that's a great way to both engage the local communities and also broaden the types of attendees and talks that you may get to these things. So the thing I want to talk about is actually front-end DevOps, and also, like the subtitle of my talk shows, I know that I'm standing between everyone and happy hours, so let's get on with it. As Dan mentioned, my name is Ryan Joy. You can follow me at ATXRyan. And I have been an organizer of Refresh Austin for about 10 years now, for over a decade. My background is as a front-end developer, app developer, so a lot of this stuff is very applicable to kind of my career and where I've come up. My actual job, though, is as a startup evangelist at Microsoft, so I spend a lot of times working with startups across a wide gamut of technologies. We're not here to talk about any of that. So a little bit about Refresh Austin real quick. So Refresh Austin is a community of designers and developers working to refresh the creative, technical, and professional culture of new media or web endeavors in their areas, specifically around design, technology, usability, and standards. You can join us at refreshaustin.org. We're also on Meetup, and we have a fairly active Slack channel. On Meetup, we have around almost 4,500 members there on that community, and around 1,000 folks on our Slack channel as well. One of the things I find interesting is, this community of designers and developers. One of the core missions of Refresh Austin is the fact that we all work in multidisciplinary multidisciplinary teams, and we have to have a common language. We have to have a common understanding of the problems we're trying to solve, the constraints that the various roles may face, or the priorities that different people or different roles may place on different things. So in a lot of ways, it actually fits in very nicely with the DevOps culture in that you have to have a culture of DevOps, and everyone has to be on the same team to understand what it is we're trying to do. Why does the DBA versus the developer versus the performance engineer, what are the different things that they actually care about? And we even extend that further, and you take that into the designer and the content developers, the content marketers, all these different players. And so within each of our meetups, and our next one is actually next Tuesday, but within each of our meetups, we have 2 speakers, usually on varying topics. So we may have an intro to grid design for people who are interested in design topics that night, as well as a deep dive on, debugging T-SQL or something. Not kidding, we don't ever do T-SQL, but something on, some intro to new data technologies or Graph API or something like that that's going to attract a different type of individual to our meetup. So whenever Refresh Austin, I should say, was invited to kind of participate in this and give a talk, I figured, okay, well, let's talk about front-end DevOps. And I decided to reach out on Slack and ask for some best practices that I could incorporate into the talk. And one of the responses I got was, do you have a quick explanation as to what is DevOps for the front end versus DevOps for anything else? And I think that's very fair, right? Like, what do you mean DevOps for the front end? How is that different than just regular DevOps? And if you take this definition of DevOps, which I think every DevOps talk has a definition of DevOps. So this is one that I kind of like, is union of people and process and products to enable continuous delivery of value to your constituents. When I originally stole this quote or this definition, it actually said delivery of value to your end users, which I think is great. But I actually think that DevOps also is important to more than just our end users. It's also important to our fellow team members. It's important to our managers. It's important to the business owners, and then of course to the end users as well. And so you're right. Whenever, under the guise of this kind of definition, what do you mean front-end DevOps? How do you separate those things out? And so my goal here today isn't to necessarily talk about best practices that are only applicable to DevOps, but really putting that mindset, that culture of DevOps within the front-end developer as well. And then why, of course. So you've got speed to feature development. You've got things like sustainable code quality, mitigation of technical debt. Obviously, technical debt constantly accumulates, but we can mitigate that with some best practices. The gentleman before this talk today before my talk was talking about the use of open source packages, and then within the front end world, that's definitely true as well, with the reliance on various plugins, regardless of the framework you're using or whatnot, that they may be incorporated into your front end project. Speed to working software environments. So just like with your total stack on the server side or cloud side, getting a developer up to speed and getting a instant working software environment is key, whether that's my local dev environment or my actual production build environment. And then of course speed to market. So DevOps is all about speed, and then sustainability. But going back to that why question a little bit more, did any of y'all see this? This was shared like a few days ago, and then there were some other blog posts and things like that that kind of picked it apart and I don't know, whatever. But this was a roadmap for a modern web developer in 2017, and I think it's interesting for a number of reasons. One, has everyone seen the meme or the joke on Twitter? It's like, create a website in 2001, open Notepad++, save as .html, done. Create a website in 2017, install Node, npm install Grunt, Grunt install this, Gulp install this. You keep moving down the list. Babel installed, or install Babel, TypeScript, what have you, before you ever even get to your first line of code. And so this roadmap that they have is very kind of indicative of that. But more importantly, if you notice, DevOps, they have DevOps completely separate, and then they have DevOps as an offshoot of backend and not at all of front end. And so that's kind of, this kind of really signifies why I wanted to talk about DevOps for the front end, because it's not a separate concern. It really, DevOps should be above both of them, and then you have front end or back end developer coming down into those. So just real quickly, this is their DevOps slide that talks about, what is the career path and what are all the things you need to know there. But if this is, I understand this is very small for everyone, but things like continuous integration and continuous delivery are also important for our front end developers. Things like monitoring and alerting, also important. The OS stuff, maybe not as much. Containers, maybe not as much, because maybe someone else on the team handles that. But maybe they don't necessarily need to do cluster managing, probably not for front-end developer. But even with the cloud stuff, they maybe, as we move more and more into microservices and functions, Azure functions, or AWS Lambda, a lot of those are going to be maintained by front-end developers versus quote-unquote back-end. And then here's their front-end developer roadmap, which, as we ignore the actual languages and things like that, you start looking at those methodologies, and you have to, anytime you see something like these methodologies, you have to wonder, well, how are these things enforced, right? So if I have a large team or a large project that I want to, it needs to live on beyond the employment lifetime or project lifetime of any one developer, how do I enforce whatever methodologies are there? How does this system not break down when it comes to sustainability? And again, that would be where DevOps would come in. And so having a DevOps mindset so that people are writing either custom linting tools or custom testing tools, doing checks before they, doing post-commit hooks for checking for things like the object-oriented CSS or the systematic CSS or any one of those things. All right. And I think more and more, beyond those checks, so much application logic is being deferred to the front end anyways. So when you look at the front end developer today, a lot of applications, whether it's Angular or Ember, a React application, if you're doing native or hybrid, if you're doing Electron.js or you're doing Cordova, kind of Apache Cordova, PhoneGap stuff, so much stuff when it comes to web, so much application logic is actually being deferred to the client side anyways, that you do kind of need this DevOps mindset to enforce these standards and things like that. And the key here also is that the frameworks themselves don't matter. It doesn't matter if these are Angular or React. It doesn't matter what your team is choosing, or if it's even native or it's vanilla JS that you're writing in-house. The frameworks here don't matter. It's about that culture of testing, continuous improvement, automation, all of those good things. Here I could probably say that DevOps is your Swiss Army knife and should be able to do it all. I don't think it's necessarily, this again is one of those situations where it's not strictly limited obviously to the front end, but just DevOps in general. So how do we approach this for the front end? So very first, and foremost, you have to have that foundation of that culture. Everyone has to have buy-in that this stuff is important, that we need to improve performance. We need to, performance is paramount to potentially the next feature that comes out, or anything else. You want small and agile teams to be able to operate in this manner. I don't know if larger teams can do a lot of this stuff. Doing code reviews and then automating the front-end build system, and then automating the deployment, which is kind of derived from that front-end build system, and then automating testing. And again, you have to have that DevOps culture so that you have to believe that this is all a good thing to do. And that's also important, if you think about it, DevOps culture, and it's important to back up to back up the person that is, making the case or arguing, for or against some practice along the pipeline. And I think a lot of times, whenever with the front end, it was just a matter of getting it done. Just implement this, whatever the design would be, or we need this charting, so just implement this thing, and you don't necessarily take into account the performance hit or these other things until it becomes some sort of bottleneck. So another thing that front-end DevOps is going to make sure, it's going to make sure that all of this stuff works on people's local machines. Actually, front-end DevOps is going to make sure that all of this works on any machine, right? So that if I download a package, I can just whatever I choose. It doesn't matter which tooling that I'm actually relying on, but that I can just do npm install and npm start if I'm relying on npm scripts, and hopefully it's going to pull down dev dependencies and production dependencies and run any sort of migration task or whatever it may be, that I can get this environment up and running on my local machine. And that should also work in production, so that I can literally run that same start script and do that stuff in production. And I think that this is important as well, because a lot of times if you start to break down the process for deployment, hopefully you're not doing this in your own companies, but I know in jobs I've worked in the past, things like uglifying or minifying or concatenating wouldn't actually be part of the build process. They may be part of the individual developer's process. And that means that I could actually skip any one of those steps, right? Maybe I minified, but I didn't gzip. Maybe I, whenever I was, delivering the actual content. If I have a really heavy image process or SVGs or things like that, maybe I'm not optimizing at that level. Maybe, where in the process are, if you look at the actual page load and the size of the pages that are being sent down, I think I have a slide on this actually, we're averaging like 3 megabytes now. And the majority of that, around 67% of that, is images. And a lot of images have Adobe kind of meta information in there that sometimes can take up more than half of the actual bytes of the image that's being pushed down. So that's a breakdown in process, if you ask me. Well, why isn't as part of the build process, to actually have a native module that scrubs that information out? Right, so just looking at any of those things that are happening, and the problem, just if I can back up a little bit, just like now we have the back-end DevOps engineer, someone who's kind of solely focused on that. I think that everyone kind of needs to buy into the culture, but ideally there would be someone that owns it. There's someone that can, call these things out and almost enforce them, that looks for these things, that can build those specific toolings that other developers can incorporate into their own workflow without it being their specific job. And that brings me to the next point. So just like with DevOps Anywhere, it's all about automation, automation, automation. Automate anywhere and everywhere. So if there's a task that individual developers are asked to do before they commit, then that probably can be automated. We no longer write JavaScript and just throw it on a page. Oftentimes today there are compilation steps. We may never be writing JavaScript. We might be writing TypeScript or ClojureScript or anything like that. And so we'll have these build and compile steps. We're also probably working in, rather than giant 10,000 line files, we're probably working in a bunch of different modular files. And so we need to actually build those into one single script for our deployments, and we're not necessarily building or working those larger scripts locally. So having that automated build and deploy is key. And then just like with anything else, whatever you do locally, you should be able to do the exact same thing remotely and just literally hit deploy and run on whichever environment you're in and however that's working. All right, so tooling. There's a ton of tooling out here. I'm not this talk, or I didn't want to get into any specifics of which ones I would recommend. Although I do use typically use Gulp or Grunt. Gulp a little bit more now, just with the streams. You can also use npm scripts. You have continuous integration hooks with Jenkins or with Travis. I think any DevOps, front-end DevOps also obviously has to be intimately familiar with Node. Even if the software that you're delivering is not Node itself, the tooling likely will be. That's just kind of one of the artifacts of modern web development. And specifically, I think, as I'm talking about automating a lot of these things, one of the quickest paths to automating your stuff is Node, and specifically writing your own command line interface with something like CLI.js or CLI.js so that other developers on your team can also run these same things. So you may have a package that is doing automation or doing some task for you, and they just call this, command line tool. And maybe the command line tool does scaffolding. Maybe it runs a suite of tests. Maybe it does that image meta extraction or a cleanup that I was talking about. Then of course, Git and GitHub are instrumental in modern development. For the front end developer, I don't necessarily care if it's GitHub or Git, just pure GUI or pure command line or GUI. Just being familiar with those tooling and the workflows of branching and however your team has decided to manage all these things. So actually one more. There's also Fabricator. This actually ties into the next slide, which is on testing. So, you know, Fabricator is a tool, and there's some other tools out there as well that will help you do testing and kind of put stopgaps in there so that, you know, if certain conditions aren't there, that you're not moving on to that next build, or you're not actually moving forward. On the testing side, again, I don't really have an opinion here. My experience is mostly with Mocha, but you know, you have things like Mocha or Karma, Cucumber, which is great if you also need to do business testing as well. So if you need your business owners to be involved in testing, they have a kind of business-friendly DSL that allows you to test against. And then, if you're going to really do testing, though, it's not only about whenever I do testing here and then testing in QA. There's also the concept of like synthetic testing or active and passive testing. So, you know, do I constantly have tests running via something like Selenium or Protractor, so that regardless of actual usage, you know, does my monitoring solution, what is the testing from like my Selenium headless browser like constantly getting, especially for those paths that may not be as trafficked as my other main, you know, routes on my web application. And then this is what I was saying before. Just like I said, so DevOps is one of those things, it should be everyone's job, but someone should own it. And I think performance is one of those things as well that should be everyone's job, but then someone should definitely own it so they can call people out on it. The average size of web pages today is 3 megabytes, but that's average, and I think there are, you know, a ton that can get even larger than that. But beyond that, beyond like the actual average size of the actual page, are things like the number of HTTP requests that a web page or app may call. So, you know, one of the things your team may want to do is consider doing a performance budget to make sure that you focus on performance throughout a project. And again, that's why you want someone to kind of own it, so they can say, hey, this is your budget. You've gone over it. Let's trade. Let's allocate. Like, what's the deal? You know, who owns that budget? And then, you know, having that budget, you know, in empowering the kind of the front end developer to say, no, we can't do this because of the hit we'll take to our budget, right? To allow them to have that power to talk back to, or to, you know, push back against the decision maker or the business owner or marketing or whomever. And so there are a few different ways that you can do kind of performance monitoring or testing. Looking at something like the size of the web page is called milestone timings. Because you can look at numbers, like you can look at number of HTTP requests, the size of the web page, all these things. But honestly, that doesn't tell you a lot, because what happens if a page loads in 3 seconds, but literally it took that entire 3 seconds before anything showed? You had 3 seconds of white paper or white page. Versus what happens if a page takes 5 seconds to load, which this one did. This was DevOps days, by the way. Sorry, DevOps days. But it displayed the majority of the content after a mere second. So which in those scenarios is better? That's a very subjective thing, but that's what we're kind of looking at when we're looking at the performance, the actual expected performance of a web page. That's something more like what could be called speed index. And there's also quantity-based metrics. So again, that's reducing just the overall number of HTTP requests, moving over to HTTP2 if you can, or things like that. And then you have things like rules-based metrics. And this is kind of your linting for web pages. There's things like, Yahoo's YSlow. There may be other rules-based things that you don't want to have a bunch of SVGs, because those are hard to parse, or maybe you don't want to have reliance on third-party libraries, or maybe making sure that everything's coming from CDN, all kinds of different things. So any one of those single milestones aren't necessarily the be-all, end-all, but hopefully they give you an accurate representation of performance, and you can have a better way to talk about these things. And then I think this particular piece is one of the places where DevOps, the traditional DevOps on the back end, significantly outpaces DevOps, or doesn't include DevOps on the front end. And that's with continuous monitoring of the application state. So, you know, here I've got a couple of screenshots from Application Insights, Azure Application Insights, and we see that we have the browser page load time of that kind of line chart. But again, if I'm going back to that performance slide, that's not necessarily the metric that's important for experience and for the end user. I'm glad that initial spike with the page load is no longer happening, but if the user is still receiving, if there's something blocking content from actually rendering on the page for a while, then that stuff needs to be captured. And so on the right-hand side, we have a little bit more in-depth stuff, also from Application Insights, but there are other tools as well, that starts to break down the impact of AJAX calls, the impact of image rendering, the impact of CSS rendering, you know, all these types of things that can be happening. And I think that's key to start to incorporate into you know, your DevOps or your front-end DevOps place. And again, this is also a case for why there should be probably someone who owns that, because if you're doing feature development, you're likely also not building the dashboarding for monitoring, you know, the performance of your web application rendered on the client in the same way that you may be doing for your backend systems. And so those are the main things I wanted to cover. There's a few things I didn't cover. One of the other feedback I got whenever I asked the Refresh Austin Slack channel, you know, what are the best practices? Their response was, well, this is a very subjective subject. What are you prioritizing? So I told them I was prioritizing deployability, automation, and testing. Some of the other subjects that came up were complexity. So again, this would be tooling that you could build in for to look at the complexity of the code bases that you're writing. So does anyone currently use those with their backend code within their .NET or Python or anything like that? Just to look at, you know, how complex is this class and the dependencies that we're passing through. Same thing with our front end code or our JavaScript modules, things like that, right? So we can start to incorporate some of those things, which again, if we go back to the constituent slide, that helps our team members and everyone else down the chain without necessarily affecting our end users, but does help with overall team dynamics. There's also things like the configurability and modifiability of an application. And then last but not least, front-end security. So I'm not talking about you know, making sure that passwords aren't in the open or something silly like that. But there's actually a lot of stuff that can happen on the front end when it comes to content security policy, when it comes to the way that images can be rendered, or the way that canvas can be rendered within a web page, and the things that you can actually glean from that. In fact, Alex Sexton here in Austin has a good talk that he gives on kind of front-end security best practices that I highly recommend you go check out. Because there's actually a good number of ways to exploit front-end security that are not yet mitigated. But with that, those were that's why DevOps are the front end. Thank you very much.